Yes, students, in this video, I'll explain you the finite Fourier sine transformation. Okay, and so the finite Fourier sine transform of f of x in interval 0L is defined as fs sine transformation fx is equal to fsp, which is equal to f bar sp, which is 0 to L f of x sine p pi x by L dx. Let us do this equation number 1. And now, where p is an integer, the function fx is also known as inverse finite Fourier sine transform of f bar sp. If you take is here, then f of inverse of sine transform of which is function of x. Yes, actually this is defined as f of f inverse s f bar of sp. You see here, yes. Okay, if you take it, the inverse of this is f of sp, which is equal to f of x. So, which is equal to 2 by L, yes, sigma p varying from 1 to infinity fs, yes, sine p by x by L dx. Okay, students, this is the where if you substitute here is L is equal to pi, yes, in this expression, then you get, yes, f of s, yes, f of x is equal to this one here, this is, and here is f of x sine px, because substituting L to be the pi. So f of x, which is equal to, yes, 2 by pi in place of L, at 2 by pi sigma p varying from 1 to infinity f bar sp sine px. Yes, this is actually the finite sine transformation. Okay, students. Similarly, we can obtain the finite cosine transformation. Yes, on the same definition as we have these properties I have proved earlier lecture, in the earlier video lecture. So for the cosine transform, yes, this is the finite Fourier cosine transformation. The finite Fourier cosine transform of f of x in 0L is defined as f of c, f of x is equal to f of c for cos f bar cp is equal to 0 to L f of x cos p pi x by L dx. Okay, where p is in integer. Okay, so so inverse of this is, yes, taking the same process. If you yes find out the inverse of this is, so inverse of c, that is the f bar c inverse, which is equal to f of x, which is equal to 1 by L f bar c plus 2 by L sigma p varying from 1 to infinity f bar cp cos p pi x by L for the cosine transformation. Yes, students, clear? So if we take similarly for here, in earlier video I have defined with some transformation for the sine and cosine transformation. So for the here you also know for the cosine transformation, you have the value is for 0 and also for, so because for of the even functions, yes. So this is equal to f of x, which is equal to 1 by L of this is for the 0 plus cos of this is. Okay, so where f of 0 c, this is equal to 0 to L f of this x cos p pi x. Yes, you know this thing. Yes, this is actually known as the finite Fourier. Here is cosine transform. Now here you also, if you substitute as L is equal to pi. If L is pi, then this can be written as f of c, f of x is equal to f of cp, f bar cp is equal to 0 to pi, f of x cos px dx. Okay, and fx is equal to 1 by pi for 0, yes, plus cos of, because of the even functions. You know the value is for 0 is also in cos term and plus of cos term. Yes, so plus 2 by pi, p varying from 1 to infinity, c cos pi. Yes, student, where f of 0x, which is the same, yes, for cosine term, 0 to L, f of x dx. Yes, student, so you have cleared it. The Fourier, this one the finite Fourier sine transform, and similarly for the finite, yes, the finite Fourier cosine transform. Yes, students, you have cleared these definitions. Okay, in next video I have defined you some other properties of the Fourier transform. Okay, thank you.